In lesson 2.10, we are dealing with an idea called multiplicity, which is really just a fancy word for how many times does each factor show up in a polynomial, and therefore, how many times is that zero of the polynomial repeated. Now, this might be easier to explain if we look at an example, so let's jump in with that in mind. In this first problem here, I noticed that I have a quadratic, it has something squared, and specifically I have x minus 3 squared, which means that my 0 here is going to be x equals 3, which I can also confirm on the graph. But really importantly, I want to point out something. X minus 3 happens twice. Remember, if something is squared, that means it's multiplied by itself, so I could also write this equation as y equals x minus 3 times x minus 3. This is what is called having a multiplicity of 2. In other words, the factor x minus 3, and therefore the 0, 3, shows up twice. In the second problem here, I have two different factors. I have x plus 1, which gives me a 0 of x equals negative 1, and I have x minus 3 again, which gives me a 0 of x equals 3. Now I want to point something out though. X equals negative 1, this has a multiplicity of only 1, whereas x equals 3, again, has a multiplicity of 2. And we'll notice on the graph that something different happens here. The x-intercept of negative 1 goes straight through the graph, the x-axis, whereas the x-intercept of 3 does something a little different. It bounces off the x-axis. It actually almost looks like a tiny parabola, whereas the blue line looks kind of like a line, goes straight through. We're going to see this pattern build up as we go through this lesson. In the next example, well, now we're back to only having one different factor. We've got x minus 3, again giving us that 0 of x equals 3. But this time it shows up 3 times. So we're going to say, hey, if I'm talking about multiplicity, this is a multiplicity of 3. And we see something strange on the graph. This time, the graph is back to going through the x-axis, but it kind of looks a little weird as it does it. It actually kind of looks like a cubic function, which multiplicity of 3, x cubed looking function, maybe we're starting to see the pattern. In the last example, when we go and check out this one, we're back to having two different factors, and this is going to look really, really similar to the second one we did, where I've got here an x-intercept of 6, and I have here an x-intercept of 3. And again, I have a multiplicity of 1 and a multiplicity of 2. And again, we see for the x-intercept of 6 that our function goes straight through it. And we see again for the x-intercept of 3 that our function kind of bounces off like a parabola. So to summarize what we saw here, and this pattern does hold up when you are dealing with multiplicity. If it is even, then the graph will bounce at that x-intercept. Graph bounces at the x-intercept. Whereas if it is odd, so that's like, 1, multiplicity of 1, multiplicity of 3, then the graph goes through at that x-intercept. There's a little more to it, like we saw here. The cubic one, the multiplicity of 3, definitely looks a little bit weirder than the multiplicity of 1 did, but that is the summary version there. An even multiplicity is going to make the graph bounce at that x-intercept, and an odd multiplicity is going to make the graph go straight through the x-axis at that x-intercept.